Today, take you into the most terrifying purgatory in the solar system. Io. Have you ever seen a moon blanketed in sulfur snow? Have you seen volcanic eruptions powerful enough to hurl material hundreds of kilometers into space? Welcome to the most inhospitable world in the entire solar system, Io. As one of Jupiter's 4 Galilean moons, Io's surface environment is nothing short of hell. Magma flows constantly across its surface. Lava lakes dot nearly the entire face of the moon. And what makes it even stranger is the temperature extremes here, scorching and frozen, separated by nothing more than a shadow's width of time. Before 1979, Io was just a faint point of light that Galileo spotted through his telescope in 1610. An ordinary member among Jupiter's 4 large moons, unremarkable from a distance. Then the Voyager spacecraft swept past the Jupiter system in 1979, and the images it returned pulled back the curtain on this hellish world for the first time. Jupiter is a gravitational tyrant. It controls over 90 confirmed moons. And Io is among its most extraordinary subjects. Roughly the size of Earth's moon, but sharing absolutely nothing else with it. Where our moon is quiet and still, chaos is written into Io's very bones. The source of Io's madness is a force operating over billions of years. As the closest large moon to Jupiter, Io is locked into Jupiter's immense gravity, while simultaneously being pulled by the tidal forces of its neighboring moons, Europa and Ganymede. Jupiter's gravity constantly kneads Io, pulling its surface up and down by up to 100 meters, generating enormous frictional heat deep within the moon, a mechanism scientists call tidal heating. The internal rock heats through constant friction. It melts into lava. Tidal heating transforms Io, sitting far out in the cold outer solar system, into the most intensely heated rocky body in the solar system. A furnace with no off switch. Io is estimated to host roughly 400 active volcanoes across its surface. At least a dozen are erupting at any given moment. A sequence of images captured by NASA's New Horizons probe in 2007 showed a single eruption at the Tavashtar Patare region, hurling a plume 330 kilometers into space. That plume was visible from telescopes on Earth. The largest volcanic feature is Loki Patera. It stretches 202 kilometers in diameter and is responsible for roughly a quarter of Io's total heat output. Scientists believe Loki Patera is a massive lava lake, where waves of overturning crust sweep progressively around the lake, triggering destabilization and sinking of the cooled surface, a process unlike anything seen in terrestrial lava lakes, because Io's volcanism is simply too extreme for Earth's mechanisms to scale up to. The lava temperatures during eruptions can exceed 1,000 degrees Celsius, far hotter than the magma produced by Earth's volcanoes. This extreme environment also sculpts Io's bizarre topography and climate. Hot lava blasts sulfur high into the sky. In the cold vacuum of space, it cools rapidly. When it falls back to the surface, it settles as sulfurous snow. The entire surface is coated in layers of sulfur and volcanic rock, yellows, reds, and whites, weaving across the moon like a strange oil painting. Those white patches are frozen sulfur dioxide frost. Io would once have had impact craters, but over billions of years, lava has filled them all in. The crust is completely resurfaced by magma on geologically rapid timescales. Nothing older than 1 million years survives on the surface. The entire planet is in a state of permanent renovation. What overturns common sense even further is Io's temperature swings. In sunlit regions warmed by both the sun and volcanic heat, surface temperatures can reach around 130 degrees Celsius. In the shadow, heat bleeds into the vacuum of space, and temperatures plunge to minus 143 degrees Celsius. When Jupiter's shadow sweeps across Io's surface, within minutes, the gaseous sulfur dioxide in the thin atmosphere condenses directly into solid frost. A real world of fire and ice, cycling constantly, without pause. The existence of Io shattered everything humanity assumed about what moons could be. Who would have imagined that a moon so far from the sun, driven purely by gravitational forces, could become the most volcanically violent body in the solar system? It is a natural cosmic laboratory, showing us the raw power of tidal forces and offering us a glimpse of what the young, early Earth may have looked like 4 billion years ago.